All right, so it is officially 7:15, so it's officially go time for me. For those online, thank you so much for jumping in to this workshop. And I think I'll give it just a few more minutes to let some more people trickle on in here. So I say 2 more minutes here, 7:18. Go ahead and officially kick it off. All right, cool. Let's go ahead and roll with it. All right, so the format that I kind of have for this is just very quickly do an introduction about myself, the course that I teach, course that I wrote, a little bit of what I do for work, for fun, hobbies, stuff like that. And then I'll dive into the meat and potatoes of all this, walk you through some code as much as possible. So hopefully some of you have a little bit of background in C or C++. If you don't, hey, that's fine because I'll slowly walk you through some of the code, explain some of the functions that I'm calling behind the scenes, and what the overall objective is for the application that we're making here. Okay, and then I'll probably formally end about 10 minutes, probably about 10 minutes towards the end. I'll cut it short. Open up for any kind of Q&A, any kind of questions you all might have about the code base, any questions you might have about the overall technique in general, pros and cons of anything, or just anything code or Windows implants, Windows dev that y'all might have, feel free to ask. So on the note of asking questions, if you have questions while I'm speaking, I do believe that you have the permissions to unmute yourself in Zoom. All right. So if you want to do that, if you feel comfortable doing so, please, by all means, go ahead and unmute your mic and fire away with your question. The chat window is also open for me, so I can come up here to this fancy little confidence monitor and I can see the chat window. So if you don't feel comfortable unmuting yourself, feel free to send your question in the Zoom chat, and I'll try to get over there and see the question. All right, so who in the world am I, and what do I do? What do I do for fun? What do I do for SANS? What do I do for a living? All that type of stuff. Okay. So my name is Jonathan Ryder. I have been in the United States Air Force for just over 20 years now. And I've been Air Force active duty, Air Force Reserves, and now I am part of the Maryland Air National Guard, where I am a cyberspace officer, where I do capabilities development for Windows and Windows kernel for Cyber Command at Fort Meade. It's been a lot of fun. I've been doing that since 2016. And when I'm not doing stuff like that, I work for Lockheed Martin, and I do a lot of stuff in the Windows kernel for Lockheed Martin. and I've been there for just about 3 years, all for Windows. So if you have any questions about things for Linux, and folks online, if you have Linux questions, I'm not your guy. I'm 100% always Windows and will forever be Windows. Okay, so that's kind of pretty much what I do, where I work and stuff that I do. For SANS, what I do for SANS is I started out being a TA and eventually worked my way on up to being an instructor. I used to teach 660 for a while. And then probably about 2.5 to 3 years ago, I made a proposal to SANS for an implant dev class for the Windows platform. And it seems like they've been waiting for a long time for somebody to come and make a class like that. So I spent about a year and a half making the class, making all the labs and stuff like that. And the course that I wrote is Security 670. And it is very, very heavy with labs. And I don't have a lot of slides. And for this particular workshop, if you will, I have no slides because I hate slides. If I could teach an entire class without slides, I would, right? Because I'm all about more hands-on, more time on keyboard, more you of learning how to do things. And to make you a developer, you have to have that time on keyboard. You have to be able to understand how to program different things. You have to understand pointers, pointers to pointers, structures, function pointers, stuff like that. Okay. So 670 has been running for just about a year, maybe just a little bit over a year now. So if you are ever interested in 670, been more than happy to chat with you about 670, some things we offer in it. And this code base, what I'm about to talk about here, is a little bit of a sneak peek of some of the things that you'll do as labs inside of 670. All right, so for this talk, I kind of want to focus on how in the world you could craft a capability for an implant that can reach out over the internet and kind of talk to your C2 infrastructure. There are multiple ways that you can do this. A lot of people can do this with raw sockets, HTTP, HTTPS, curl. There's curl libraries you can bring into your code base and make communication requests that way. But for this, what I'm going to be focusing on is the Windows preferred way to make HTTP requests. There are two primary libraries that Microsoft recommends that you use. That's WinHTTP and WinINet. Right, so MSDN documentation, for what it's worth, tries its best to be very accurate. And some of my students this week have been finding out that MSDN documentation isn't really that reliable with how they describe their functions, how they describe some of the arguments that get passed to the functions. And so the running joke is, how many times is MSDN wrong with their documentation for Windows functions and the parameters? And so far, it's not looking good for MSDN. All right, so inside of an implant, you want to talk back to your C2 infrastructure at some point in time, because if you don't, what's the point in dropping an implant on a system? Okay, so I talked about WinHTTP and WinINet. MSDN has a nice little breakdown of different features for both of those libraries, WinHTTP and WinINet. What I'm going to demonstrate for you is how you can use the WinHTTP library to implement TLS communications. I love using TLS communications because I don't want people to try and sniff around and figure out how in the world my implant is communicating with my C2 infrastructure. I don't want commands going across in plain text. I don't want to see on the wire somebody at the C2 infrastructure typing in something like PS list, sending that over as straight plain HTTP over to the agent side, and it parsing just strings. Okay, that's not good. So we want to make sure that you're using HTTPS, TLS, if at all possible. Any version of TLS would be preferred. Okay, so let's start walking through the code base a little bit here. All right, so I mentioned before, if you're brand new to C or brand new to C++, this might be a little bit more of a challenge for you to digest and for you to take in. But I will do my best to go ahead and break everything down and explain what I'm doing and explain what the functions are doing. Quick little shout out to my Intro to C series that's hosted on SAN's workshop website. What I'm doing is I'm teaching folks how to do C programming for Windows for free, right? Assuming that you have no experience whatsoever with C, check out that series because that's targeted for you. Okay, so I have nine parts out of 10 are already recorded and up there on the SAM's website. So check it out when you get a chance. All right, so to get started with this code base, what's happening here is I'm just including some header files, basically some libraries that I need to bring in to access the functionality that are defined inside of these header files. So I'm bringing in Win HTTP because I'm going to use a lot of their functionality to go ahead and implement an HTTP GET request with TLS. And one of the things I want to do here is I need to be able to implicitly link against some very specific libraries. Think of these like DLLs, if you will, right? So we have these .lib files, and I have to link against it because when I compile this thing, it needs to know where some of these functions are actually located, where the code for those are actually stored. Believe it or not, when you open up a project inside of Visual Studio, it does not automatically include every single .lib file, every single library file that it possibly could, okay? Because there are hundreds of library files that they could include on your behalf, but they choose not to. They choose to include only the core minimum that you would need to basically create a pretty good Windows application. So because of that fact, we know there are 2 library files that aren't in there. And so we have to bring them in manually using a preprocessor directive. Okay, so that's what the pragma statement is doing right here. This preprocessor directive is saying, hey, I want you to go ahead and find this win.http.lib library file, and we are going to link against that when we go ahead and build this entire solution file. Okay, we also need to go ahead and link against the crypt32 library file because when we go and we inspect the certificate for our C2 infrastructure, if you will, or just google.com here in this example, we need to use some of the functionality that crypt32 provides. Okay, so those 2 lines take care of the implicit linking. Okay. All right, so next up is I am using just a hard-coded domain and path. And all I'm doing here is saying google.com, the search I have, the query that I have for you is security 678. Okay, so this could be your C2 infrastructure, whatever IP address or whatever domain your C2 infrastructure is, you can have that inside of your implant. Okay, we can talk about strings, obfuscation of strings, how to hide data, how to hide your C2 infrastructure information all day long, but we don't have time to jump into that for this one. The next variable that I have is for the fingerprint. And if you're wondering how in the world did I get this value, where did the SHA-256 value come from? Okay, so if you open up a web browser and you go to Google, all right, come on. I don't think it's going to go. It should be a lot faster than that. Oh, man. All right, well, scratch that, okay? But in any case, one of the things that you can do is go to google.com and you can click on the little lock icon to go ahead and take a look and inspect the certificate for that particular domain. And all I did is scroll down to the SHA 256 area of the certificate, copied that out, and pasted it inside of my code base. And the reason why I'm doing that is it's a way for me to go ahead and implement something called certificate pinning. Certificate pinning, if you haven't heard of it before, is a way to go ahead and try to detect possible attacks like any kind of untrusted cert that might be shoved in the middle of your traffic, any kind of unknown proxy that might be shoved in the middle of the traffic, saying, hey, something or someone is in the middle of your traffic between the implant and your C2 infrastructure, and maybe you weren't expecting it whatsoever. You want to be able to see that and take action if the certificate doesn't match, the certificate thumbprint or the hash, if it doesn't match. Okay, so depending on what you need for your situation, your operation, if it doesn't match, a lot of times you can just go ahead and abort, have your implant terminate itself and clean itself off of the target system. Okay, so again, this SHA 256, a lot of times what I do for my own projects is I do a lot of self-signed certificates for my C2 infrastructure. Okay, so self-signed certificates can be a little bit challenging to deal with. And you'll see here in a second some of the flags that you can specify for these functions to basically ignore certain warnings or issues about self-signed certs. Okay, so moving forward and moving down in the code base here, we've created basically a custom function that is going to act as a callback. It's a callback function because I'm curious about the different states of my requests. So as my request goes out and it's going across the wire, I want to be aware of any kind of issues or just the overall status of what's happening. Okay, so it's going to be calling back into this function right here. Okay, and then inside of this, I have a few variables here that are pretty important as far as how to hold and how to extract the certificate from the server that you are hitting. Okay, so one of those structures, one of those specific data types is the cert context. And so let me go ahead and let me show you what this looks like. So I'm just hitting F12 to bring up the header file where this particular structure has been defined. Okay, so inside the cert context, I have a couple of fields. We have the encoding type. We have a byte pointer to the encoded cert. We have the size of the encoded cert, and then we have the certificate information, and then we have the cert store. Okay, so we can go ahead and call another API here in just a second to have all of that stuff filled out for us. That way, later on, we can dive into these fields and inspect them and say, hey, is this the certificate that I expect to see? And if it is, cool. This must be the C2 infrastructure that I was paired with when Implant was built and when the C2 side was also built and launched and stood up. Okay, so if not, then maybe we want to take some kind of evasive action and get off of that system because maybe something is in the middle. All right, so I'm going back to the code base here. So we created that structure, and then I'm going to call this function here, when HTTP query option. Okay, so query option takes in just a few small parameters, but the most important piece here is this one right here, the when HTTP option server cert context. That's a mouthful, right? That's a lot right there. But basically, we're passing in the flag that says, hey, I am interested in grabbing the context for this certificate for this server. That way you can go ahead and inspect it. Now, The next piece that we have to do here is we have to figure out the length of the certificate information, because we really don't know at compile time how long or how big the certificate data is. Okay, it can be dynamic, all right? We don't really know ahead of time. So we have to go in and dynamically figure that out at runtime and dynamically allocate a chunk on the heap to store that information. So one of the things I'm teaching my students this week is how to figure out the size of something that you need, something that you don't know at compile time. So for this particular case, the API that we have to call here, we have to go ahead and make it fail. We have to intentionally make it fail just to get the size of the buffer that we need to store all of the information about the server certificate. So how do we do that? Well, if you've never seen this particular function before, you can do one of two things. You can hit F12 and kind of see the header file, where this is coming from, where it's been defined. And a lot of times, Microsoft is pretty good at doing documentation inside the header file. So you can see all these comments here, basically talking about some of the constants for different property IDs as they relate to a certificate. All right, so I'll talk about property IDs here in just a second. If you've never seen some of these prefixes here, like in, out, write, bytes, optional, in, out, what those are called SAL annotation. They are source code. It's basically a source code annotation language. It's a way for you to properly describe how function parameters are going to be used within that function body. I can't tell you how much code I have looked at where it is very difficult to understand how a particular parameter is going to be used. You pass a pointer to something, okay, cool, but is the pointer for when I'm passing you, is that going to be treated as read-only? Are you going to modify that buffer or whatever I'm pointing to? Are you going to reassign the pointer to something else? What exactly is going on? All right, so SAL annotations are an awesome way to basically increase the readability for your code base. All right, so what's going on here is for this first parameter, it says in, the annotation says in. Okay, so that means this is required. I cannot pass in a null pointer for this particular argument. It has to be a legit pointer to the type cert context. Okay, cool. The next piece we see also has an in parameter, and that is the prop ID or the property ID. All right, so what is it that you're trying to get from the certificate? And then we have a crazy one called outright bytes to optional. And the optional there is basically saying you don't have to specify this. Okay, so what's going to have to happen inside this function body is it's going to have to check to see if a null pointer was passed for this particular function. All right, and what's very interesting about that is if it is a null pointer, then the function will go ahead and treat the next parameter as an out. All right, so you can see the annotation for this piece being in out. All right, so what happens here is if I pass in a null pointer for that third parameter, then it will go ahead and tell me the size of the buffer that I need to allocate to store all the information about the server certificate. All right, so let's go ahead and see how we actually call the function. All right, so we mentioned the property ID. Okay, so the property ID that we want to get from this certificate is the SHA-256 hash. Okay, because we hard-coded the hash up here. Now we want to get this dynamically from from the certificate to make sure that it matches. All right, so the next piece, that third parameter, this is when I'm passing in the null pointer. Okay, so again, passing in null pointer there will go ahead and make this function fail. And when it fails, it'll go ahead and write to this variable, and it'll fill it in with the value that I need to make the buffer. So we automatically assume that it fails. So I don't even bother to go ahead and check the return value. And some of you online, you're probably thinking, why in the world, how crazy are you that you're not going to check the return value? I'll say, well, in this particular case, I don't care, because I already know I am going to intentionally fail this function. Okay, so the next piece that I do is I need to go ahead and dynamically allocate a chunk on a heap. And how much space do I need? Well, we just figured that out. Because of the previous call that we failed, we know exactly the size of the buffer to go ahead and hold everything from the server's certificate. Okay, so cool. We make the allocation. Awesome. But just because we made the allocation doesn't mean there's anything in it just yet. So now we have to go ahead and call that function one more time. But this time we go ahead and say, I have a pointer for you, right? Again, remember I passed in null pointer previously. Now I have a buffer. Cool. The buffer is there. It has the right size. That way it can hold everything that it needs. And this time I will make sure that I'm doing my proper error checking. Okay, so we do the error checking to make sure that's good to go. If not, we go ahead and make a simple print statement, grabbing the last error message, the last error, and we'll go ahead and dump that out. Say, hey, it failed for whatever reason. So sweet. Assuming that it's good to go, one of the next things that we're going to do is we're going to go ahead and get ready to store the hexadecimal value of the hash from the certificate. Okay, because at this point in time, it's not ready to do any kind of comparison with what we have already stored internally inside of our implant. Okay, so that's what we're kind of doing there. We're getting it ready to go. And then finally, we can go ahead and start to do our comparison. Okay, so we compare the SHA-256 hash that we just dynamically retrieved from whatever's directly in front of us. Okay, it could be a proxy. It could be somebody implementing like a man-in-the-middle kind of attack or something like that we're not expecting to be there. And then we compare that with our hard-coded hash. All right, again, the hard-coded hash is what we expect to see. That's what we want to see, to let us know that we have a direct line of communication with our C2 infrastructure. So if that does not match, then we come down here and we jump into the code for the else. And all we're going to do here is I just want to have some kind of awareness of what is in the middle between me and my C2 infrastructure. So to do that, I want to get some more information about that certificate. There's tons of information that you can pull, but just at a minimum, what I'm pulling here is subject name and the issuer. And then I just go ahead and display that to standard out and then say, hey, you know what? I don't feel safe to go ahead and continue with my operation. I need to go ahead and abort, get the heck out of town. So I'll terminate my process. A more mature implant would do something like maybe get yourself cleaned out of memory. We would go back to our allocation that we made on a heap. We would overwrite that. Obviously, we would free that as well, and then zero it out again. That way, nobody can have any kind of forensic evidence that we were there. So we can completely clean ourselves out of memory. Okay, so all of that, this whole function, is basically our way to check against a known good certificate. Okay, then we have to get into the actual meat and potatoes of sending off our request. Right, so we're going to do this with this wrapper function called when HTTP get. Okay, so a lot of times a target system, especially at an environment or whatever, it might have a proxy setting already set up for the host. So we might want to go ahead and get that configuration. So when HTTP get IE proxy config for the current user, we can go ahead and grab that and we can display that. Okay, so the next piece down here, calling crack URL to go ahead and split off the domain portion and the path portion. That way we can go ahead and display that just for some extra information. Okay, so that gets printed out to standard out. And then we're coming in and displaying more information about the proxy to see what has been set for this current host and its current user. And then right here is where we start to dive into the actual when HTTP functions. Okay, so when HTTP open, this function is going to basically be the initializer for this process. We can't do anything else until we have everything initialized for this particular application. You only have to call this one once, and it's good for the entire lifetime of the program. Okay, so if that's good to go, and we pass our little error check, we can go ahead and move on and specify that we want to speak TLS. Okay, there's no reason your implant should be doing HTTP comms. All right, so HTTPS, and you can see here we're trying TLS 1.1, TLS 1.2. Okay, and then we'll go ahead and we'll set those options for this current session that we speak TLS. Okay, and then we want to say, hey, you know what? I have a callback function that I want you to call when you are going through the motions of sending off the request. And we go ahead and give it the address of our cert pinning callback function. All right, that's everything I just described above to go ahead and do our check against our known good certificate hash. When HTTP connect, this is when we go ahead and take our handle session. And we'll go ahead and say, all right, I see the host name or the domain name or the IP address for your C2 infrastructure, and also see the port. We'll go ahead and get ready to make our connection. Now, this API will not send off any packets to the target space. Okay, we're just getting ready for that. Okay, so moving on down to when HTTP open request. This is where we get to specify the verb for our HTTP request. And you could do post, you could do get, you could do head, connect, any one of the HTTP verbs that are supported, you can go ahead and issue them here. Okay, so for a get request, all we're doing here is passing in the handle for the connection that we just got from the previous call, the path for the URL, and saying we don't have any kind of refer, and then these two parameters don't really matter, and then all the flags that we set, all right, to force HTTPS. On the note of flags, I mentioned earlier in the talk that you can specify certain flags or a combination of flags to deal with any kind of self-signed certificates, right? So I mentioned that when I do my own dev for my own projects, create my own C2 infrastructure just to play around with it, I'll go ahead and generate some self-signed certs. Okay, so one of the things you have to do when dealing with self-signed certs is say, hey, you have to ignore certain things about the cert. So ignore unknown, ignore the wrong usage, invalid CN, invalid date, so on and so forth. There's a few more options that you could set as well. So once you have all of those established, you can go ahead and call when HTTP set option to go ahead and set those options. And then we also want to disable redirects. Okay, so we'll go ahead and set that option too. So up to this point, we have not sent off any kind of packets, any kind of request, any kind of data from the system to the C2 infrastructure. Nothing has gone out yet. That's going to come here for when HTTP send request. All right, so send request. What it takes here, I know it kind of looks a little bit ugly. I can go ahead and break some of these things down on a new line. We'll keep the zeros together. Okay, so basically what we have here is what we're going to send off to our C2 side is not a whole lot of information, okay? Because we're not sending a post request, okay? There's nothing formally that we need to send to the C2 infrastructure for any kind of processing. We didn't get a command. We don't have results from a task or anything like that. We're basically, all we're doing right now is trying to check that we are indeed talking with our trusted C2 infrastructure. Okay, so the next piece we have to do here is we have to go ahead and say, hey, what response came back from our request? So we say when HTTP receive response. And if that's good to go, then we'll go ahead and skip over all of this error handling stuff, and we'll move down to this function right here. This function here is to actually go ahead and make a query to see what kind of data came back, if any, okay? So if it was good to go, we can go ahead and dump some results about how many bytes we received from the server. Okay, so that's enough talking. That's a lot of talking about the code base. But doing a thorough code review and introduction to the code, I think, is vital. All right, and especially vital to understanding what's going on here. Okay, so right now, we'll go ahead and fire this off, and we will see if anything is in between us and our intended target, which is Google. And right now, I need to double check my internet connection. I think that's why it didn't load before. So let's see. Wait for it. Oh, goodness. Can't you see I'm trying to do a demo here? Let's see. Give me just a second. Let me enter in this one. What we got here? All right, cool. So success, right? Awesome. We're online. All right, now I can go ahead and compile this and just straight up run it all at the same time. Okay, so the output, I know the font might be a little bit small for folks online. Hopefully y'all can see that pretty well. So you can see there's no proxy that's been set for my VM. The host name's google.com. The path is the search and the query of 670. TLS, yes, true, because we are indeed using TLS. Port is 443. And then dynamically, we pulled out the certificates, the SHA-256 hash, or what some people call the fingerprint. And that is this hex value here. Cool. Now, this piece, this is the one that we baked into the implant itself and say, hey, this is the known good. So we do a little compare, and it says the certificates match. Awesome. Now, when the certificates match, that's when you can go ahead and officially check in, if you will, with your C2 infrastructure. Your check-in a lot of times can be a HTTP post request, because you're going to send some data to your C2 infrastructure to say, hey, I'm alive. I've vetted you. I know you are my C2 infrastructure, so now we trust each other. And now I'm going to send you some information about the host that I'm on. Could be the host name, could be like the machine GUID, could be the user account that's active, internal IP address information, any kind of stuff that you think might be useful for an initial check-in. All right, cool. And then we received about 235 bytes from the server. Okay, awesome. But now I kind of want to show you what happens when something is in the middle. Okay, so I have Fiddler installed. If you've never heard of Fiddler before, very similar to Burp Suite. It's just a proxy. And I have it set up to decrypt HTTPS. All right, so TLS stuff. And what should happen, hopefully, after my machine unfreezes here. There we go. Okay, so what should happen this time is it should detect that there is a proxy in between me and google.com, which is basically just acting as our C2 infrastructure. So let me go ahead and run this again. Okay, so look at that. Now, the new fingerprint that we have starts with 9A, obviously wildly different from the known certificate that we baked into the implant. And because of the mismatch, we'll just say we're going to abort the mission. Okay, and then I said I wanted to grab some information about whatever certificate we find in the middle. So we grab the subject, and the subject here says created by Fiddler, do not trust. Okay, cool, whatever. The issuer here, do not trust Fiddler root. Okay, so kind of cool. So our implant, if you will, is kind of safe. Okay, and this method is what we call certificate pinning. And a lot of organizations do it. Microsoft does it. There are a lot of things on Windows, Windows 11, Windows 10, and earlier. A lot of things they do certificate pinning as well. Apple, I think, used to or still does. A lot of things on Android they do as well. So certificate pinning is still very heavily used today. And I use it all the time when I'm building my implants, trying to speak to my C2 infrastructure. Okay. Also, you could do a Wireshark. You could run Wireshark and grab a PCAP of everything. And what I love to do about that is I love to make sure that my traffic is actually using TLS. I want to make sure that I see the actual, the client hello, the whole exchange of the certificate. I want to see all of that happening and use that as validation that one, the code works, the implant behaves as expected, and that your comms between your C2 and the implant are protected. Okay, so that's pretty much all I have. All right, so just to recap quickly, going over Win HTTP libraries, Win HTTP functions to implement TLS communications, and implementing a certificate pinning feature to make sure that you're talking to your trusted C2. And when we introduced that proxy using Fiddler, we found that discrepancy with whatever cert it had, and we said, nope, this doesn't match. I don't trust it, so we're going to go ahead and get out. Okay, so that's it in a nutshell. That's all I have for you. We are about 10 minutes-ish until the end of my time slot. So I'll go ahead and open up to any questions that y'all might have. And if not, we'll go ahead and say adios. This is that awkward silence that everybody loves so much. It's like, I don't want to be the first person to ask a question. Cool. I'll give it one more minute for some questions. Y'all a pretty quiet bunch. Cool. So no questions. All right. Awesome. Assuming you're all now experts at certificate pinning, experts at C++. So thank you, Carlton, Dana, Eric, Georgios, Leonard, Masukazu. Sorry for butchering any names. Thank you so much for attending tonight. You have a good evening.